Some rigs use a Kelly and rotary table to rotate the drill string and bit. This system consists of the swivel and rotary hose, the Kelly assembly, and the rotary table. Some rigs use a top drive system to rotate the drill string and bit. A modern top drive, also called a power swivel, is an integrated unit that includes a pipe handler assembly, block, swivel, and a powerful motor or motors to rotate the drive shaft. Crew members make up the drill string to the drive shaft. Crew members make up the Kelly to the swivel stem. The Kelly has either 4 or 6 sides and passes through a 4 or 6-sided opening in the Kelly drive bushing. The Kelly drive bushing mates with the master bushing. So, when the machinery inside the rotary table rotates the master bushing, the Kelly drive bushing rotates the Kelly and attached drill string and bit. The Kelly is flat-sided, with either a square or hexagonal cross-section. It's square in this drawing. It is hollow, so that drilling fluid can flow through it. The Kelly moves through a square or hexagonal opening in the Kelly drive bushing. The Kelly drive bushing mates with the master bushing in the rotary table. The rotary table turns the master bushing, the Kelly drive bushing, the Kelly, and the attached drill string and bit. The Kelly can move vertically while rotating. The rotary table performs 2 functions. First, it transmits rotary motion to the master bushing, which drives the Kelly and drill string. And, with assistance from slips, hangs the drill string. The master bushing goes inside an opening in the rotary table. Small master bushings are usually a solid single piece, as shown here. Large master bushings are either split or hinged. Crew members install a 2-piece or split insert bowl in a receptacle in the center of the master bushing. The insert bowl is tapered inside and supports the back of the slips. They come in various sizes. The crew changes out the insert bowls to match with the type of slips in use. Insert bowls are also called inserts or bushings. Rotary tables have openings that range in diameter from 17 to 49 inches, 43 centimeters to about 1.2 meters. The smallest can hold a non-moving load of 250 tons, about 225 metric tons. The largest can hold a non-moving load of 800 tons, about 725 metric tons. Some small rotaries can spin as fast as 500 revolutions per minute, RPM. Large rotaries spin a bit slower, with upper ranges of about 300 RPM. Manufacturers taper the inside of the insert bowl. They taper it to match the taper of the back of the slips. The slips grip the drill string and suspend it inside the insert bowl. The insert bowl fits inside the rotary table's master bushing. Suspending the drill string in this manner allows crew members to disconnect the Kelly or top drive and break out joints of drill pipe. Crew members can remove the insert poles to provide a larger opening through the rotary table. If necessary, they can also remove the master bushing. They may have to do this to run a large hole opener bit or large casing. Casing is pipe that the crew runs to line the walls of the hole after they drill it. A rotary table and Kelly system includes a swivel and rotary hose. The swivel has a bail, like the bail or the handle on a bucket, only much larger. The swivel bail hangs from the hook on the traveling block. The swivel allows the attached Kelly and drill string to rotate. At the same time, the rotary hose conducts drilling mud into a curved pipe called the gooseneck. The gooseneck attaches to the swivel and carries drilling fluid to the swivel via the wash pipe. The rotary hose is flexible, steel-reinforced hose that allows the swivel to move up and down within the mast. A passageway inside the swivel stem conducts the high-pressure drilling mud into the Kelly and drill string. Here is an isolated view of the swivel. The bail hangs the swivel from the hook, which is not shown. The rotary hose conducts drilling mud to the gooseneck. Mud flows through the gooseneck, down the wash pipe, and into the stem and drill string below. Wash pipe packing seals the high-pressure mud in the wash pipe as the stem rotates. The stem rotates on heavy-duty radial bearings and thrust bearings. The main thrust bearings support the entire weight of the drill string as it rotates. Swivels have dead load capacities ranging from 150 to 1,250 tons, about 135 to 1,125 metric tons. Some rigs use a top drive system to rotate the drill string and bit. A top drive has a powerful motor, or motors, and a drive shaft. The crew attaches the drill string to the drive shaft. When the motor rotates the drive shaft, the attached drill string and bit also rotate. Crew members attach the top drive to guide rails, or tracks, which keeps the whole unit from rotating. With a top drive, the rotary table does not rotate the drill string. The most important benefit of a top drive is that it reduces drilling time. It also rotates the drill string more efficiently than a Kelly and rotary table system. Further, it handles stands of pipes more efficiently. A top drive system provides more variable rotating power than a rotary table. It allows drill string rotation and circulation at any point in the hole when tripping in, drilling, or tripping out. These features help prevent hole problems. It provides rapid response to well kicks during tripping or running casing. The driller can make up and remotely shut the built-in IBOP to stop drill string flow faster than a crew can set slips, stab, and close a full opening safety valve. In highly deviated holes, it helps to prevent the pipe from getting stuck by allowing the driller to immediately ream or back ream the drill stem. If the crew can make up 3-joint stands of pipe before drilling starts, a top drive can drill triple stands instead of just 1 joint, as is necessary on a Kelly drive rig. Making up 3-joint stands reduces the number of connections required to 1/3. In many cases on large offshore rigs, the crew no longer needs to lay down pipe between wells. That is, the crew can set stands back vertically in the derrick, and the rig can be moved a short distance without the pipe being laid down. Top drives have a few disadvantages. They are more expensive to maintain, and they are very large. Because of the additional weight, the rig's drilling line wears faster. They are more difficult to move on land rigs that must be disassembled. A top drive does not use a Kelly or the rotating components of the rotary table. The top drive includes a traveling block and an integrated swivel. The rotary hose conducts drilling mud to the integrated swivel via an S-pipe assembly. A passage inside the swivel drive shaft directs mud into the drill string. The top drive motor connects to the traveling equipment at the integrated swivel assembly. Drive motor horsepower ranges from 600 up to 2100, or 420 to 1500 kilowatts. The motor turns the main drive shaft through a gearbox or transmission. Crew members make up a saver sub on the bottom of the drive shaft and make up the drill string onto the saver sub. The saver sub cuts down on wear and tear to the drive shaft's threads. Top drives have hoisting capacities ranging from 350 to 750 tons, or 315 to 680 metric tons. Guide tracks or rails in the mast keep the top drive unit from rotating as the motor and the drive shaft assembly turn the drill string. The top drive dolly assembly moves up or down on the guide rails. Service loops, which are bundled cables and hoses, transfer the required electric, pneumatic, and hydraulic power between the mast standpipes and the junction boxes located on the top drive. The top drive unit also includes a pipe handler assembly that has an upper inside blowout preventer, IBOP, a lower IBOP, and a torque wrench. The torque wrench makes up or connects and breaks out or disconnects joints of drill pipe. The driller controls the top drive's operation from the console. The pipe handler assembly also includes links, an elevator, and an automated link tilt assembly. The driller activates the link tilt assembly to position the links and elevator at the mouse hole for picking up or laying down drill pipe. The link tilt assembly also assists the derrickman in racking stand. The rig's mast is a strong tower that supports the equipment attached to the traveling block and hook. Crew members sometimes use the words mast and derrick interchangeably. In reality, a mast stands independently on the rig floor and is raised as a single-piece unit. In the old days, rig owners used a lot of derricks. A standard derrick, as it's called, is usually bolted together. It has 4 legs, beams, and girts or cross braces. Unlike the mast, the derrick cannot be lowered or raised as a single unit. Today, masts are much more common than derricks. Manufacturers usually weld and pin the mast together for easier assembly and disassembly. A self-erecting mast may be a cantilever type, a folding type, or a telescoping type. A mast or derrick is tall, normally having a clear height from 100 to 160 feet, 30 to 50 meters. They are also strong. They are able to support static weights ranging from 275,000 pounds to 3¼ million pounds, or 125,000 to 1½ million kilograms. A rig's mast must be tall enough to allow crew members to set back drill pipe, tubing, and other tubulars they pull out of the hole during a trip out. It also has to be tall enough to allow the driller to raise the traveling block above the height of the derrickman's monkey board. With the traveling block high in the mast and the elevator at the derrickman's position on the monkey board, the derrickman sets back drill string elements or stands. Most rigs pull 3-joint stands of drill pipe and drill collars. A 3-joint stand is 3 made-up joints of drill pipe or collars. Small rigs may pull 2 or even 1-joint stands. In rare cases, a really large rig may pull 4-joint stands. Regardless of the number of joints, pulling pipe in stands instead of a single joint at a time speeds up the tripping process. The working platform at the top of the derrick or mast that permits access to the crown block is called the walk-around. It is also called the water table. The monkey board is the derrickman's working platform when crew members pull pipe or run it back into the hole. The derrickman sets stands of pipe back into a fingerboard, a platform with projections that holds the top of the pipe in place as it stands in the mast. A stabbing board is similar to the monkey board. It is a small platform in the mast or derrick, about 30 to 40 feet, or 9 to 12 meters, above the rig floor. A drilling crew member, usually the derrickman, works on the platform when running casing or tubing. The derrickman guides the top of the casing or tubing from the stabbing board. The crew member called the stabber adjusts the stabbing board's height with a hydraulic, electric, or air-powered motor. The height varies depending on the length of the casing or tubing being made up and run into the hole. The substructure is a rugged set of beams. It supports the mast or derrick and the heavy hoisting and rotating equipment. It also supports the drilling tubulars on the rig floor. It must be high enough to accommodate the blowout preventer stack underneath the rig floor. Crew members hoist pipe and equipment from the catwalk up to the rig floor by raising it up the pipe ramp. They hoist it onto the rig floor through the V-door. Crew members make up the Kelly to the swivel stem. The Kelly has either 4 or 6 sides and passes through a 4 or 6-sided opening in the Kelly drive bushing. The Kelly drive bushing mates with the master bushing. So, when the machinery inside the rotary table rotates the master bushing, the Kelly drive bushing rotates the Kelly and attached drill string and bit. The Kelly is flat-sided.